So today, we're jumping into a really cool story. It's about a year-long quest by a team of ex-Microsoft engineers to build, well, a true AI partner for data analysis. They basically asked a huge question. Could an AI agent finally take on the most boring parts of data work and, get this, maybe even do it better than a human? All right, let's get into it. Just look at this number for a second. 80%. Now, what if I told you that this is how much time some of the most brilliant data analysts spend on work that has absolutely nothing to do with being brilliant? And there you have it. That's the core problem the Bayeslab team wanted to solve. It's this quiet, unglamorous truth that people in the trenches know all too well. You have these highly paid, super creative analysts who are stuck being, essentially, digital plumbers. They're just cleaning data, fixing formats, and writing the same old queries again and again. It's just a massive waste of brain power. So, here's our game plan for today. First, we're going to dig a little deeper into this 80% problem. Then, we'll look at how the team picked the right AI framework, the actual brain for their agent. After that, we'll get into the really cool stuff, the 5 architectural pillars that make this whole thing work. Then we'll see its most amazing feature, self-healing code. And to wrap it all up, we'll talk about what this means for the data analyst of the future. Okay, so let's get right into that 80% problem. And let's be super clear. This is not about analysts being bad at what they do. Not at all. This is about biology. See, we humans, we're fantastic at strategic thinking, at seeing the big picture. But when you ask us to do repetitive, exhaustive tasks, which is pretty much the definition of that plumbing work, we just have some built-in limitations. And this slide really nails the difference. A human analyst, we get tired. We have our biases, right? We subconsciously look for answers that confirm what we already think. And hey, when a deadline is breathing down your neck, you often just stop at the first answer that seems good enough. But an AI agent, it has infinite patience. It can test 50 different hypotheses with the exact same level of rigor, check for outliers every single time, and it never ever gets tired at 2 in the morning. That consistency, it's a genuine superpower. All right, so the problem's clear. But the next huge hurdle for the team was picking the foundation. I mean, with new AI frameworks popping up on GitHub practically every week, which one could actually stand up to the pressure of real enterprise-level data analysis? So they put the big names to the test. You've got frameworks like AutoGen and Crew AI, which are all about these multi-agent chats. Well, they turned out to be a, and I quote, nightmare for deterministic logic. Basically, they were too busy talking to each other to just follow a strict set of steps. Then you have Semantic Kernel, which is solid, but was a little slow to get the newest Python features. And then they found deep agents. It hit that perfect Goldilocks zone, just the right balance of control and freedom. So here's the key takeaway, right? They didn't just need an AI that could call a few tools. They needed an AI that could actually think like a data scientist. And that's why they picked deep agents. It was built on a foundation of 5 absolutely critical architectural pillars, which really act as the blueprint for this new kind of AI partner. So let's break down that blueprint. These 5 pillars are really the heart of the solution. They're what takes this thing from being just a simple chatbot and turns it into a reliable, autonomous analyst. First up, pillar number 1, deep planning and intent. This is all about understanding what you really want, not just the words you typed. It's like seeing the whole iceberg of your question, not just the tip. So how does that actually work? Well, instead of just rushing to write some code, the agent's planner takes a vague question like, hey, why did our churn spike? And it breaks it down into a really detailed plan, a whole roadmap. It figures out all the statistical tests it needs to run, which customer groups to compare, what timeframes to look at. All of that happens before a single line of code ever gets executed. The second pillar is all about control. If you're going to have an AI this powerful, you absolutely need to give it some guardrails. The team calls this cognitive scaffolding. And this isn't just a polite suggestion. It's a set of hard-coded rules delivered through system prompts. The agent is literally given a strict mental template with commands like, you must check for outliers before you plot a chart. This forces it to follow the same strict standards a senior human analyst would, which massively cuts down on the risk of mistakes or, hallucinations. Okay, pillar 3. This one solves a huge, real-world headache. Massive data sets. You can't just cram a database schema with 500 columns into an LLM's context window and just hope for the best. It'll just break. So what the agent does is pretty clever. It uses a virtual file system to handle these gigantic schemas, so it never overloads its own memory. It uses a technique called RAG, retrieval augmented generation, to intelligently pull in only the pieces of information it needs for the specific task it's doing right now. And maybe most importantly, it has long-term memory. It remembers the business context you told it about 10 minutes ago, so it never just blanks out, even when it's deep in a really complex analysis. Next up, staying on the cutting edge. I mean, let's be real. The quality of an AI analyst depends completely on the power of its brain, the underlying large language model. This framework is built to let the team plug in the latest and greatest models, like Claude 3.5 Sonnet, the very day they're released. But what's really smart is how it uses them. It can switch on a model's most powerful and most expensive reasoning modes for the really tough statistical problems, but then it'll automatically switch back to a faster, cheaper model for simple stuff like data cleaning. It's all about using the right tool for the right job and saving money while you're at it. And that brings us to the fifth and honestly the most revolutionary pillar of them all, the agent's ability to fix its own mistakes. This changes the entire game. So let's talk about self-healing code. The team knew from the start that in data analysis, failure isn't some rare event, it's the norm. So they thought, why not build an agent that doesn't just put up with failure, but actually learns from it? This quote just says it all, doesn't it? An analyst's daily life is a minefield of errors. Code breaks, queries time out. Any system that can't handle that brutal reality is just destined to fail itself. So what happens when the agent's code actually breaks? This is the magic part. Instead of just crashing and giving you an error message, the agent pauses. Then it reflects. It actually reads the error logs to figure out exactly what went wrong. Was it a syntax error, a memory problem? And then, and this is the amazing part, it automatically refights its own code and tries again. It's this automated debugging loop that happens in seconds, without a human ever getting involved. So, as you can probably imagine, this kind of technology has huge implications for the role of the data analyst. We're talking about a massive shift in where we provide value, moving away from all that manual, tedious plumbing work. And this all leads to a brand new concept they're calling vibe analysis. The most valuable skill for an analyst in the future won't be writing perfect code. It'll be the ability to direct the AI, to critique what it finds, and to shape its raw insights into a powerful business strategy. Your job literally shifts from being the plumber to being the director. So we'll end with the same provocative question the Bayeslab team is asking. This autonomous partner is here, and it's ready to handle that 80% of the job that nobody really wants to do. The only real question left is, what are you going to do with all that reclaimed brain power?